Hello, everyone. Thank you so much for having me. I'm excited to talk about some tools for understanding and assessing blue carbon, specifically emissions and removal dynamics in blue carbon ecosystems. I'll be going through three quick case studies, hypothetical case studies. None of these are real, but hopefully they're case studies that illustrate a few different ways that you can use some of the tools that are available. Before I get started, I want to say a big thank you to all the partners that worked on the products. This was definitely a team effort, and many of the people who worked on the products I'm going to be talking about are actually on the call today, such as Chris Janicek, who was just speaking, and Laura Brophy. So the two specific tools that I will be showcasing through these case studies are a new explorer called Blue Carbon in Yaquina Estuary. That's an explorer tool that, as by the name, really focuses in on the Yaquina Estuary in Oregon. And I'll also be talking about the Pacific Northwest Regional Blue Carbon Calculator, which again, by this name, is a more regional scale tool. And I'll be going more into the data behind these and the actual applications within the case studies. The Yaquina Estuary tool is available now. I'll share a link to it at the end of this presentation, and the calculator will be coming soon. But there are going to be some opportunities for beta testing, which I'll also share at the end how you can get involved with that if you want to. So the three case studies I'm going to walk through. First is just an exploration case where you might want to explore dynamics associated with a specific area within an estuary. The second case study is more of an assessment if you might have a restoration project that is already happening, but you're curious to understand what the dynamics might change based off of your restoration actions. And then the last is a comparison and how you can use the tools together to assess different actions in different areas. So starting with the first case study here, exploring emissions and removal dynamics associated with current tidal wetland habitat type. So in this hypothetical scenario, you might be engaged in pre-project planning, not have any specific restoration site identified, just generally curious and exploring the estuary, figuring out where restoration might be useful for blue carbon co-benefits. So the specific tool that you could use for this particular use case is the Blue Carbon in Yaquina Estuary tool. I will say we're working on duplicating this for the Coos Estuary, and this might be duplicated for other estuaries along the Oregon coast. These are somewhat pilot examples. Okay, so this is a screenshot of what the tool looks like. It's an interactive map where you can click on sites and get a pop-up with additional information about the site. So in this situation, this blue horseshoe is highlighted. So that's what the pop-up is showing. This specific data layer is habitat type based off of CMEX. There's also a carbon flux layer. In this tool, we're using carbon flux more generally to talk about emissions and removals. So in this case, that same horseshoe we were just looking at has a net emission of carbon over time. This is available at 3 different timescales: 15 years, 30 years, and 50 years, and is shown cumulatively on the map, but is also available as annual numbers within the actual data set itself. And this is based off of local data and greenhouse gas methodology that was used for Oregon's blue carbon inventory. So here in the pop-up, you can see again some more information about the site and also a chart showing how carbon flux is changing over time. This tool also includes a layer that indicates restoration status. These are shown as patterns so that you can see it on top of habitat type or on top of carbon flux. This shows restoration in terms of existing wetlands, if there has been any restoration at all. And this can be used to identify areas that might benefit from restoration. This was created by the Nature Conservancy. And then lastly, shows areas where either active restoration or passive restoration has taken place. So this is a great way to just understand the data that's already available and maybe narrow in on where you might want to do some more specific assessments. In the second case study, now the scenarios we might want to assess actual changes in emissions and removals resulting from a restoration project. So maybe your restoration project is already planned, ongoing, or completed. Maximizing carbon storage might not be a goal of the project, but you might still be interested in exploring what the outcomes are of that. This could be useful for reporting. In fact, this particular tool that we're going to use for this case study, the Pacific Northwest Regional Blue Carbon Calculator, one of the initial goals was to help the state of Oregon account for blue carbon when reviewing grant proposals and reports. So this case study somewhat aligns with that particular use case. And I'll say here at the top that this tool is based off of a range of best available data for the Pacific Northwest as a region. But this is not a replacement for a site-specific analysis, but is a more approachable way to explore this information at a larger scale and maybe help indicate where some more site-specific assessments might want to focus. So to use the tool itself, it is a downloadable Excel sheet. You'll have to enter your project name, salinity range, elevation range, and choose a global warming potential option that you want to use. From there, you'll enter the acres of tidal wetlands that are going to be disturbed, restored, enhanced, or conserved throughout your project. And then you click go, and it makes all the results for you. So here's a screenshot of the Excel sheet itself. Nothing is filled in here. So for this particular example, we might fill in with 15 acres of reed canary grass, 75 acres of wet pastureland before restoration occurred. And then after restoration, that will turn into 90 acres of tidal forested wetland, 30 acres of tidal scrub shrub. This is a complete made up scenario, so I don't have anything real life to point this to. But you'll also see here at the top, we have selected salinity ranges between 0.5 and 5 PSU, and that the site itself is above mean high water. So then we click go. And we'll get a few different ways of viewing the results. The first are these summary tables that show cumulative and annual emissions and removals in multiple years post the project occurring. So 5 years, 10 years, 20, all the way up to 100 years. And this is broken down by actual above ground, below ground emissions and removals, methane emissions, and then all of those put together with minimums, means, and maximums to help indicate some of that level of uncertainty. And this is also available within the results as graphs. So graphs that you can easily just pull and put into your report. So here on the left side, we're seeing a below and above ground biomass over time. These middle charts are showing methane. And then the ones on the right bring it all together. Again, showing minimums, means, and maximums. And a future goal for this tool, once the Excel sheet is all tested and approved, this is going to be put into an online tool. We're kind of calling it the TurboTax method because we want it to be easy, where it'll prompt you for exactly what you need to put into the tool in order to get this wonderful output report. All right, so our last scenario here is bringing it all together using both of those tools to compare different land management actions and understand their effects on carbon emissions and removals. So in this scenario, you might be planning a restoration project torn between a couple of sites, wanting to compare the different current conditions of the site and future conditions. Again, going to say here, this is not, neither of these tools are a replacement for site-specific analyses, but are really low-hanging fruit for some initial assessments. So for this, I'm going to be showing how you can use both the Blue Carbon in Uinta Estuary Explorer and the Blue Carbon Calculator. And again, this is totally made up scenario. For this, I focused in on Mill Creek and Little Beaver Creek. Little Beaver Creek actually is like behind a large dike. So this is, again, an example, not really feasible, but is meant to show the different ways we can use these tools. So using the Equina Explorer, we can see some of the current conditions of the sites. They're both currently agricultural land that were previously tidal emergent wetland. They differ in terms of salinity class. Little Beaver Creek has lower salinity. Mill Creek is tidally connected, whereas Little Beaver Creek is not tidally connected. Mill Creek is partially restored. Little Beaver Creek is unrestored. And the Equina Estuary shows that without restoration, they're both still operating as sinks, but at slightly different magnitudes across 50 years. And getting a little bit more in detail with the tool, we can see that they are sinks, but actually over time, they're becoming less sinky. They're starting to emit more over time. So this is just an interesting way of getting a better understanding of the time components here. So for the blue carbon calculator, these are what we'll input in. I'm not going to show all of the inputs themselves, but if Mill Creek were to turn into tidal emergent wetland, Little Beaver Creek for this scenario, maybe we're turning it into a mixture of tidal forested wetland, tidal scrub shrub wetland. This could be identified based off of elevation, right? So how the site is going to be changing over time. And using the calculator, we get these results. So 50 years post-project at Mill Creek, with restoration, the cumulative removal is 278 tons of CO2e. Without restoration, it was actually 346. So we're seeing that through restoration, this might actually increase emissions at Mill Creek. And then for Little Beaver Creek, we're seeing that with restoration, the cumulative removal in 50 years is 3,920, which is a higher rate of removal than without restoration. Again, these are with error bars, and this is based off of regional data, not site-specific data. So this is just a first pass. But what's interesting here is it shows that restoration in some cases can actually increase emissions. And one of the reasons why we see that is because of methane. So just digging in a little bit deeper with the calculator, we can see why Mill Creek might become more of a source is because of methane emissions that are increasing here with restoration, which is something that happens. So with that, I know I went through those really quickly, but I'm happy to answer any questions. I'll put the link to the Equina tool in the chat. And please shoot me an email if you're interested in being a beta tester for the blue carbon calculator.